In this video, I'm going to do a slightly more advanced use substitution problem just to make sure you've got the basic idea down. They don't tend to do real easy ones on the AP exams, so understanding the concept and actually being able to apply it are not necessarily the same thing. So here's an integral between 2 and 5 of x e to the 2 minus x squared power. So the way we would normally handle this is we would say, okay, the derivative of the inside function is negative 2x. I have an x, I need a negative 2. We'd balance with the negative 1/2 out here. The negative 2x would go away when we reverse the chain rule and we go from there, all right? With U-substitution, you let your inside function be your U value, okay? And so now I can replace that with a U, okay? But I also need everything else. I still have this x here. I don't know what's going on with that. I've got this dx here. Okay, so I need to get a du statement. Okay, remember that dy is equal to the derivative times dx. We're not doing a dy here, we're doing a du, but same thing. Du is equal to the derivative, negative 2x, times dx, okay? And I want to replace the dx, okay? So I'm going to solve for dx. I'll divide both sides by negative 2x, okay? And that tells me that dx is equal to du over negative 2x, okay? So I will kind of replace the dx with all of this. So I've got a du over negative 2x. I'm going to write that as a 1 over negative 2x, okay? And what you should see here is, oh, we have an x that cancels that x right there. I can factor this 1/2 out in front. So I've got a negative 1/2 e to the u du. Remember, the last thing that I need to do, these bounds, these limits on the integral, also need to be in terms of u. And right now they're in terms of x. So when x is equal to 2, 2 minus 2 squared is negative 2. And I'll replace that with a negative 2. When x is equal to 5, 2 minus 5 squared, that'd be 2 minus 25. That's going to be negative 23. Okay? So those end up being my new bounds in terms of u. And then you can go through the fundamental theorem and all of that. So the antiderivative here, of course, would just be e to the u. Of course, we've got that constant out there as well. We're going to evaluate it between negative 23 and negative 2. And anyway, this gets pretty messy at this point. But anyway, we'd have negative 1/2 e to the negative 23rd minus negative 1/2 e to the negative 2nd, and that would be a very messy integral. But the point is, that's how U-substitution works. Again, when we do the problem, we would have said, hey, I need a negative 2x here, and I'm going to balance with the negative 1/2, and you're still going to see that showing up out there, okay? The U-substitution just a little bit more formally shows what's going on in the background when you reverse the chain rule. So it's not really different than what we've done. It's just terminology and again, a little bit more technical view of the backwards process that we've been working through. But I hope that helps you understand the process a little bit better.